Astronomers have been looking for something big, something strange hiding far beyond Neptune. But spotting it is extremely difficult as it doesn't show up in any images. However, its influence is felt in the orbits of distant icy bodies. Scientists call it Planet 9, and they have been hunting for it for years. Recently, while searching for signs of this elusive ninth planet, astronomers stumbled upon something unexpected and extraordinary. In 2017, a newly discovered dwarf planet candidate emerged, but it isn't just an addition to the list of distant dwarf planets. It might be pointing to something inconvenient, something that could contradict the very reason we started searching for Planet 9 in the first place. Astronomers have just identified what could be a new dwarf planet using observations from the Dark Energy Camera in Chile and the Canada-France-Hawaii telescope. The discovery wasn't made through a single lucky image, but by carefully analyzing 7 years of archival data, which revealed 19 separate detections, enough to reconstruct its orbit. Once they mapped it out, they found the object follows a near extreme orbit. Named 2017, OF201, it travels in a long elliptical path around the Sun. At its closest, it comes in at about 44.5 astronomical units, just a bit beyond Pluto, but at its farthest, it swings out past 1,600 astronomical units. For scale, that's over 50 times farther than Neptune. One orbit takes about 25,000 years. That's not just far, that's outer Oort cloud territory. The object itself is estimated to be around 700-kilometer wide. The interesting thing is, it's not interacting with Neptune. It's just out there. No one's sure how an orbit like this even formed. One idea is that 2017 OF201 had a close run-in with something big, maybe a planet, that flung it into this stretched-out path. Over the past several years, astronomers have picked up on something unusual. A handful of distant objects beyond Neptune, known as trans-Neptunian objects, or TNOs, weren't behaving the way you'd expect. Instead of having orbits pointing in all directions, a surprising number of them were aligned in similar ways. Their orbits were clustered, tilted, and stretched in the same general direction. And when that happens in space, it usually means something massive is influencing them, something we haven't seen yet. One idea was that a giant planet, 5 to 10 times the mass of Earth, was out there disturbing their paths. That's where the whole Planet 9 theory comes from. But here's the twist. 2017 OF201 doesn't follow that pattern. Its orbit is totally out of alignment with the others. And that is a problem, because if Planet 9 exists and is the reason for the orbital clustering we've seen, then objects like OF201 shouldn't exist. At least not in a stable orbit like this. 1. In fact, simulations show that if you add Planet 9 into the model, OF201 gets kicked out of the solar system within 100 million years. So now we have a contradiction. Either this object is a fluke, or the Planet 9 model needs serious revision. And it doesn't stop there. 2017. OF201 spends only about 1% of its orbit close enough to be seen, which means we may have just caught it at the right moment. If that's the case, it could be just the tip of the iceberg, suggesting there might be dozens, maybe even hundreds of other objects out there with similar orbits and sizes, still hidden in the dark. Right now, the dwarf planet is relatively close to the Sun in the sky, from our point of view on Earth. That means the researchers need to wait about a month or so before they can conduct follow-up observations. They are also hopeful they can eventually secure some time to scan the object, using the James Webb Space Telescope. Until then, the possibility of Planet 9's existence is still on the table. Here's how. The simulations only used one specific location for Planet 9, but not all scientists agree on where the hypothetical planet lurks. In fact, Konstantin Batygin, one of the scientists who first proposed the existence of Planet 9, says that the discovery of 2017 OF201 doesn't prove or disprove anything. Speaking with NBC News, he said, "The objects in the outer solar system that are likely to show a footprint of Planet Nine's gravity are the ones where the closest points on their orbits around the Sun are still distant enough that they don't strongly interact with Neptune. This one, unfortunately, does not fall into that category because its orbit is very chaotic." Meanwhile, Sihao Cheng, who led the discovery of 2017 OF201, said that he has not abandoned the hope of finding Planet 9 as the whole project started as a search for it. So if you're holding out hope for a ninth planet in our solar system, don't give up just yet. In fact, a team of astronomers at National Tsinghua University in Taiwan may have cracked the code with an unexpected approach and could be closer than ever to its discovery. The object itself, likely, is that Planet 9? It's more massive than Earth, probably a little bit less massive than Neptune. It sits right in between that terrestrial to giant icy planet range. Its orbit, unlike the orbits of the known planets, is not nearly circular and planar. Instead, it is exceptionally wide, 20 times bigger than the orbit of Neptune. It's just a tiny speck, a faint dot hidden in old telescope data from two sky surveys taken 23 years apart. And yet, this faint dot might be one of the biggest discoveries of our time, because if this turns out to be what scientists think it is, it could be the long-rumored Planet 9. But why do astronomers even think Planet 9 exists in the first place? In 1781, an English astronomer named William Herschel was scanning the sky with a telescope he built himself. He was looking for comets, but instead he stumbled upon a new object that didn't quite behave like a comet. Over time, astronomers realized this object was orbiting the Sun like a planet, slow, steady, and distant. They named it Uranus. But with more observations, astronomers realized Uranus didn't move the way Newton's laws said it should. Its orbit wobbled, just slightly, but enough to raise eyebrows. A French mathematician named Urbain Le Verrier worked it out with pencils and paper and concluded that maybe there was another planet pulling on Uranus. He even calculated where this mystery planet had to be, based entirely on Uranus's strange behavior. When astronomers pointed their telescopes at that spot in the sky, lo and behold, they found Neptune, right where the math said it would. Fast forward to 2016. Two scientists, Mike Brown and Konstantin Batygin from Caltech, noticed something strange. They were looking at the orbits of a few distant objects in the Kuiper belt when they noticed a pattern. These orbits weren't random. They were clustered, tilted in the same direction, as if something massive was tugging on them. When Mike and Konstantin followed the data, it led them to a wild possibility. The only thing that could explain the strange orbits of these Kuiper belt objects was a hidden planet, something 5 to 10 times the mass of Earth, far beyond Pluto. So far, in fact, that we might never see it with visible light. They called it Planet 9, and ever since, astronomers have been on its trail, chasing shadows at the edge of the solar system. The farther away something is, the harder it is to see, especially if it doesn't reflect much sunlight. So to find Planet 9, scientists went digging through two infrared surveys of the sky, one taken by the IRAS satellite back in 1983, and another by Japan's Akari mission between 2006 and 2011. This brings us to the latest development. A team led by an astronomer at National Tsinghua University in Taiwan did something clever. They looked for objects that showed up in both surveys, but not in the same place. The idea is that if something moved slightly between the two, time, periods, it might be orbiting the Sun, just very, very slowly. Now, this isn't like tracking a comet blazing through the sky. Planet 9, if it's there, would be moving at about 3 arc minutes per year. That is tiny. To put that in perspective, the full moon is about 1/800 arc minutes wide. So how do you even spot something like that? That's where parallax comes in. You know when you hold a finger in front of your face, close one eye, then switch to the other, and your finger seems to jump sideways. That is parallax. In space, we use Earth's orbit around the Sun to create the same effect. By observing the sky from different points in Earth's orbit, astronomers can detect slight shifts in the position of distant objects. With enough time, you can use those shifts to estimate how far away something is and whether it's moving. Based on this, the team searched for objects that showed up in the same place at the same time every year, canceling out parallax. Then, they narrowed it down further by checking if those objects were slowly drifting over time. Eventually, they found one, a faint dot in the IRAS data from 1983 and another dot 47 arc minutes away in the Akari data from 2006. Could it be the same object? Could it be Planet 9? Possibly. Because based on its brightness in the infrared data, it would have to be more massive than Neptune. So what happens next? If we know roughly where it was in 2006, we can try to spot it again with powerful optical telescopes. But here's the problem. In the years since Akari spotted it, this object would have moved, and we don't know where. But we do have tools that can help. The dark energy camera in Chile, for instance, has a wide enough field of view to scan the right region of a sky. And soon, the Vera C. Rubin Observatory will come online, offering even deeper and broader surveys of the sky. So it's possible, even likely, that if this object is real and still glowing faintly, we'll see it again. But not everyone is convinced. Mike Brown, who helped propose the Planet 9 theory, took a look at the data himself.